Okay, thank you for joining this lesson. We're going to discuss mathematics, equations of a straight line, and gradients. Number 18, we are told that a straight line, L1, passes through points P, 5, -2, and Q, -3, 4. Find the equation of L1 in the form AX plus BY equals to C, where A, B, and C are integers for 3 marks. So let us look at the solution for this part. The first thing we should get is the gradient. And you know that the gradient is usually given by change in y out of change in x. Therefore, we will take change in x and change in y. 4 minus -2, then divided by change in x going to be -3 minus 5. So the gradient is going to be, the numerator will give us a +6 out of, the denominator will give us -8. So when you simplify, we're getting -3 out of 4. That is the gradient for the line. So now we can express our gradient by saying that the gradient -3 out of 4 is usually given by change in y, which will be y minus 4. If I pick the second coordinate here, then I divide by x minus -3, which becomes a +3. At this point, I can cross multiply, and 4 multiplies with y minus 4, making it 4y minus 16 equals to -3 multiplies with x plus 3, making it -3x -9. Then now we can arrange the equation in the given format here. AX, so I begin with the part with x. So this one becomes a +3 at this side. X plus 4y. This is equivalent to -9 plus 16. So -9 plus 16 becomes a +7. So that is the equation in the desired format. So we can continue and say, the second part, which is part B, telling us that a line L2 passes through R03 and is perpendicular to L1. Find the equation of L2 in the form y equals to mx plus c, where m and c are constants. Therefore, we should say that gradient 2, which is the gradient of a perpendicular line to line 1. If gradient 1 equals to -3 out of 4, then gradient 2 should be the reciprocal with the opposite sign. So the reciprocal with the opposite sign, such that when the two are multiplied, they give us a -1 for the condition that they are perpendicular to one another. Therefore, we can now say that because the equation 4 out of 3 equals to, now we express our gradient y minus 3 out of x minus 0. Then at this point now, we can cross multiply, whereby 3 multiplies with y minus 3. So 3y minus 9 equals to 4x. But now remember, the equation has to be rearranged in the provided order. Therefore, 3y equals to 4x minus 9. Then y equals to 4 out of 3x The 9 becomes positive to this side, sorry. So when I'm dividing by 3, this should also become 3. Plus 3. Therefore, this is the equation in the desired format. Then we are again told to determine the point of intersection between L1 and L2. Where two lines intersect is the simultaneous solution for the two equations for the given lines. Therefore, when I solve the equation for L1 and the equation for L2 simultaneously, I'm going to get their point of intersection. Therefore, the equation 3x plus 4y equals to 7 and y equals to 4 over 3x plus 3. When I solve these two simultaneously, I'll be able to get the point of intersection for the two lines. Because y has been already expressed, we can use substitution, whereby we will say 3x plus 4, and instead of y, remember I'm rewriting equation 1, but where there is y, now I will insert this. So I'll have 4 over 3x plus 3 equals to 7. So I'm going to have 3x plus 16 over 3x plus 12 equals to 7. So that we may group like terms together. This is going to be 3x plus 16 over 3x equals to 7 minus 12 becomes negative 5. So I'm having a 3. Okay, remember 16 over 3 can be written as a 5 and 1 over 3. Therefore, when I add 3, I'm getting 8 and a third, and 8 and a third x equals to negative 5. This one can also be written as, remember this is a 25 over 3 x. So this is equal to negative 5. So that we may talk of multiplying by 3 over 25 and 3 over 25. So that x becomes negative 5 times 3 over 25. So the value of x is going to be, by 5, 1 by 5, 5. So negative 3 out of 5. That is the value of x. So we can now substitute to get the value of y and say, then according to this equation, y is going to be, we take 4 out of 3, then negative 3 over 5, which is the value of x, plus 3. So we're going to say, this is a negative 1. So negative 4 over 5 plus 3. Let me carry out that one. (2.2). So the value of y becomes 2.2. This means the point of intersection now is going to be, this is negative 0.6 when we make it a decimal, so that we may say the coordinate of intersection now is negative 0.6, sorry. We write it well. negative 0.6, and 2.2. So that is the point of intersection for the two lines. The next is going to be another line L3 is parallel to L1 and passes through R. Find the x-intercept of L3. Find the x-intercept of L3. Therefore, the gradient for L1 is equal to gradient for L1, that is the M1, is equal to negative 4/3. Therefore, the gradient for L1, negative 3/4, sorry. It's negative 3/4. Negative 3/4. That means the gradient for the third line is also the same now that they are parallel to one another. So we can first of all find the equation. Whereby we say negative negative 3/4 negative 3/4 equals to point R. It passes through point R. Therefore, y minus, let me check point R. The coordinates of R are 0, 3, 0, 3. So x minus 0, making it just x. Then now we can say, when we cross multiply, 4y minus 12, because 4 multiplies with everything here, negative 3x. Then now we are saying at the x-intercept, the value of y equals to 0. At x-intercept, y equals to 0. Therefore, at this point, we will say 4 into 0 minus 12 equals to negative 3x. So that we may say, that is work for another question. So that we may say negative 12 equals to negative 3x, and the value of x when we divide through by negative 3 becomes positive 4. Therefore, the x-intercept of L3 is equivalent to 4. So that is how we carry out such a question. Remember to continue consulting us through 07 04 153 366. You can also join our online classes so that we may continue revising together. Thank you so much.